Good morning. This is your stats sensei, Mr. Spensei, and we're going to do the exit ticket. And the exit ticket refers to an interval we've already run, but we'll go back through that real quickly. So the EPA requires that the mean exhaust emissions for a certain car size to have no more than 1.4 grams of nitrous oxide per mile. A car manufacturer claims their new process reduces the mean level of exhaust emitted for their cars. A simple random sample of 33 cars, so we know that they took a sample of 33. Is taken, and the mean level exhaust emitted for that sample is 1.27. So our X bar is 1.27. They tell us it's skewed, and they tell us our standard deviation is 0.54. All right, so in the previous one, we ran a test and we checked the conditions. Let mu equal the true population mean amount of nitrous oxide. That's our parameter. Our conditions, the random sample of 33 was given. We checked the N is less than 10%, and we found out that it needed to have at least 330 cars. And we can assume that they do, even though it doesn't say that. It told us it was skewed, but our sample size of 33 is greater than 30, so it's normal by central limit theorem. Then we use the inverse norm to get a Z star for 99%. We found out our Z star was 2.5758. We plugged everything into the formula, and we did that by going to a Z interval, and I'll do that real quickly. Stat test number 7. 0.54 was our standard deviation. The sample mean was 1.27. Our sample size was 33, and our confidence level is 99. So there is our interval 1.0279 and 1.5121. So I just took that and I brought it on over because that's our interval. So we need to write our conclusions. Now remember, we need to conclude, and then we also need to explain the level. So we are 98, we are 99% confident that the true population mean level. In our previous, we said we defined our parameter as mean amount of nitrous oxide emission, mean level of nitrous oxide emissions lies within the interval. And we state our interval 1.0279 to 1.5121. Okay, so that takes care of that part, but we need to take care of defining our confidence level, which is in repeated sampling, we expect this method to capture the true population. What do we want to capture? Mean level of exhaust emission, mean exhaust emissions, mean level of nitrous oxide emissions. How often do we capture it? Well, we ran a 99% confidence interval, so we capture it 99% of the time. So our method works 99% of the time, which means 1% of the time it doesn't. Based only on the interval you created, can we be certain that the car manufacturer's new method really reduces emissions below 1.45 at the 99% level? Justify your response. This is tricky. Because we have an interval of 1.0279 to 1.5121. So we know our sample mean of 1.27 was definitely lower than 1.45, but 1.45 lies within the interval. So it's possible that it lowered it, but we can't be certain because it's contained. So it is possible that it is lowered, but we cannot be certain because 1.45 is contained or lies within the interval. So it's pretty tricky there. It's possible because it goes really low, but we cannot be certain because 1.45 is contained in the interval. To be certain, our interval could not have gone higher than 1.45. It would have, if it stopped just below 1.45, then we could be certain. All right, appreciate you watching. Hope to see you on the next one.